Hi guys, and welcome to the second lecture for Chapter 13. Today we're going to be talking about air pollution, specifically outdoor air pollution. We're going to be going over some common terminology, as well as some of the effects of air pollution and what has been done to sort of clean them up or mitigate their release. So first and foremost, it might be useful to introduce a few definitions. Air pollution is the action of releasing toxic chemicals which would adversely affect climate as well as the health of biological organisms such as you and me. And then air pollutants are actually the specific chemicals which cause air pollution. So air pollution is the action. Air pollutants are the noun, or basically the root cause of air pollution. Those are the chemicals that we release which cause the adverse effects that we just talked about. Now, it's also useful to note that outdoor air pollution is somewhat different from indoor air pollution, something we're going to be talking about later. Outdoor air pollution, otherwise known as ambient air pollution, is the release of those toxic air pollutants in areas that are outside of human infrastructure. So outside of homes, outside of buildings, basically into the broader environment, not inside the indoor human environment. And this is one of the good news stories in environmental science. Outdoor air pollution has been reduced drastically, something we'll talk about in just a minute, over the last few years as a result of improved technology as well as improved U.S. and governmental policies, specifically in developed countries. In developing countries or undeveloped countries, we still have a ways to go, but for most modern and up-to-date countries, we've done a pretty good job in reducing the amount of air pollution in our outdoors. Now, greenhouse gases, something that we're going to actually be talking about at length in Chapter 14, we still have a very long way to go as far as mitigating climate change, but for toxic air pollutants, we have done a great job in lowering the emissions. Now, it wouldn't be right to just talk about human air pollution because there are quite a few sources of natural air pollution, three of which that we're going to go over briefly are fires. Fires are natural, wildfires in particular, even if they're human-caused occasionally. Lightning strikes often trigger forest fires, and as a result, forest fires are considered a natural source of pollution. And they're a source of pollution in that they release a lot of soot, a lot of ash, as well as a lot of CO2 as they are burning all of the wood underneath them for fuel. Second are volcanoes. Volcanoes are very much a random geologic hazard, something we talked about at length in Chapter 11, and they release things like carbon dioxide, sulfur dioxide, ash, soot, and particulate matter as they explode or as they erupt. And they can do this in very tremendous quantities. However, the frequency at which volcanoes actually erupt is very minimal, and so they're not a huge contributor to air pollution, even though at one single dose they do release a lot at one given time. Finally, dust storms release a lot of dust and aerosols. Aerosols can be any sort of particulate matter. They actually normally have a cooling effect on the environment, something again we're going to be talking about at length in Chapter 14, but it's very hard to breathe, and they can stir up particulate matter that can stay in the air for days to weeks at a time and travel great distances across the globe. Now, outdoor air pollution, specifically human-induced outdoor air pollution, can be separated into two basic categories: point source air pollution and non-point source air pollution. Point source air pollution are specific points where we release air pollution out into the broader environment. This is something we've also talked about at length in the water pollution sections of Chapter 12, but this is specific spots where large quantities of pollution are released. Basically, you can think of power plants or any large factory which consistently discharges pollution from a single source and large quantities. Now, this is very easy to control because we know exactly where the source of pollution is coming from. We can figure out where it's coming from at its source. We can control it very quickly, very easily, and it's typically very easy to regulate this type of pollution. Contrast that, though, with something called non-point source pollution. Non-point source pollution is pollution from diffuse, multiple sources that occur in very large scales across many areas. Now, these can be things such as automobiles, which release CO2 or smog or different pollutants from many diffuse sources. And because they come from so many areas, non-point source pollution is much harder to control. We can't really locate one single source when there are thousands of sources. And so as a result, it takes large-scale policy and technology improvements to control non-source pollution, as well as behavioral improvements, in order to control these forms of pollution to lower the total amount of pollutants in the area that result from indoor or non-point source air pollution. So those are the two big sources of air pollution. Now we're going to go a little bit more into the types. So when we refer to air pollution types, we're normally talking about the ultimate root cause of the pollutants, and we can break this down into primary pollutants and secondary pollutants. Primary pollutants are pollutants which are harmful immediately after their release. So basically the chemical that we release into the environment is harmful in its direct released form. Now those are going to be things like carbon monoxide, sulfur dioxide, nitrox, nitrogen dioxide, and then most hydrocarbons which are emitted as a result of burning fossil fuels. Contrast that though with something called secondary pollutant or pollution. A secondary pollutant or secondary pollution refer to pollutants which are formed from gases that react normally with the ambient environment once they've already been released. So these pollutants aren't necessarily harmful the moment they're released, but they will react with something, normally sunlight, to produce a far more harmful chemical than what they were when they were originally released, and so they are pollutants in their secondary form. So after a reaction with the ambient environment, they become a toxic chemical that then can harm organisms or the environment at large. Another important thing to make note of is a term known as residence times. And residence times are simply the amount of time a pollutant will stay in the atmosphere after it's been released. Now, you should know that residence time has a very noted and pronounced effect on the damage or the impact that a given pollutant can do. For example, pollutants with short residence times can't really travel far because they fall out of suspension very quickly, and typically their impacts are very short and very local in scale. And these are going to be things like sulfur dioxide, nitrogen oxides, and then particulate matter, things that fall out of suspension very quickly, and so they can't travel very far. Now contrast that with pollutants with long residence times. These are pollutants that stay in the air for a very long time after they've been released, and as a result their harmful impacts are very long term, simply because they stay in the air for a very long time. And because they stay in the air a long time, they can also travel to very large distances. So they don't necessarily have local impacts. They can have impacts that are very far-reaching around the entire globe. And these are going to be things like carbon dioxide, methane, and chlorofluorocarbons, things like we're known as CFCs, which can stay in suspension for a very long time and have very global, far-reaching impacts. Now, the Clean Air Act has been the primary legislation in the U.S. that has funded research on pollution control and set policy implications for how many pollutants can be released and in what quantities. Basically, it sets standards for air quality, air quality limits, as well as limits on emissions. And so basically, the EPA sets standards for emissions as well as the limitations for how many of the quantity of pollutants that can be emitted in a given area. And then in addition, state and local agencies will monitor and report to the EPA for emissions. So basically, if state and local agencies don't comply, the EPA can then step in and then enforce the law. And when we talk about what those state and local entities monitor, it is useful to talk about the 6 major criteria air pollutants. These are the 6 major air pollutants outlined by the Clean Air Act that the EPA monitors to make sure that none of these reach levels which are harmful to human health as well as organismal health in the environment at large. Now, the first is going to be carbon monoxide. Carbon monoxide is a colorless, odorless gas produced normally by incomplete fuel combustion in vehicles. Next, we have sulfur dioxide. Sulfur dioxide is a colorless gas with a very pungent rotten egg odor, and it's primarily produced as a result of burning coal for electricity in coal power plants. Next, we have nitrogen oxides. This is a family of toxic compounds, so it can be one nitrogen with 1 oxygen, 1 nitrogen with 2 oxygens, so nitrogen dioxide, nitrogen monoxide, nitrate, nitrite, different forms of nitrogen in combinations with different numbers of oxygen atoms. So a variable family of toxic compounds that are formed from nitrogen oxygen, which react at very high temperatures in vehicle engines. So as we are burning fossil fuels, the ambient nitrogen that is just there in the air as a result of the majority of air in the atmosphere being N2 will, in very hot temperatures, will react with ambient oxygen to result in the nitric oxides. Now, moving forward, we also have volatile organic compounds, or also known as VOCs, and these are carbon-containing chemicals emitted also by vehicle engines that are also a variety of solvents, industrial processes, and household chemicals that are very volatile. They're very toxic in that they normally can affect breathing quality and lung health, and they sometimes can also be carcinogenic, which means that they can also lead to cancer if they are inhaled frequently over a very long period of time. Moving forward, particulate matter is basically solid or liquid molecules which can just stay in suspension for a long time. Normally they can be pretty toxic if they're inhaled over and over again, and they can get lodged in the membranes of the lung and cause severe breathing problems if they're inhaled consistently over a long period of time. This also can result from dust or soot, which are whipped up through natural sources, as dust or dust storms are whipped up in desert areas where there isn't a lot of roots or vegetation to hold the sand or soil down. Finally, lead is a heavy metal that enters the atmosphere as particulate matter, usually after combustion. For a very long time, lead was used as a knock in engines in order to keep the engine burning fuel more stably. And so this used to be a problem, but it's since been phased out with other chemicals, so we don't really see lead as a major criteria air pollution or air pollutant these days, simply because it's been phased out of its use and it's no longer really a problem. Note that a lot of these criteria air pollutants are either formed from vehicle pollution or from coal power plant pollution. And they're all formed as a result of fossil fuel combustion. So this should give you a note as to where this pollution is actually coming from. Now, when we talk about the 6 major criteria air pollutants, it's also useful to know in what quantities that they exist. For example, carbon monoxide contributes to 63% of all, by volume, of all criteria air pollutants emitted. Next, we have nitrogen oxides and VOCs, which contribute each about 13% by volume to the amount of air pollution emitted into the atmosphere. Sulfur dioxide is next as a result of coal power plant burning, which is about around 9%. And then particulate matter and lead are very, very small in that they don't normally result from vehicle pollution or from coal power plant pollution, simply because lead has been almost completely phased out in developed countries, and particulate matter doesn't really stay in suspension very long. And so these two are going to be less severe in terms of the 6 major criteria air pollutants, and so we're going to worry primarily about the other 4. And this is again a good news story. We have reduced emissions substantially in all 6 major criteria air pollutants, particularly in lead. So in total emissions from the 6 pollutants have declined about 60% since the Clean Air Act was implemented in 1970. And this is despite increases in population, energy consumption, miles traveled, and every other metric, which means that we are burning more and more fossil fuel. But as a result of the technologies and the policies that we put in place, we have actually limited and continued to limit these different air pollutants in quantity and in volume into the atmosphere. So this is a good news story. We are lowering our concentrations and our volumes of air pollution into the atmosphere. And this is in addition to policy. We've come a long way in our technologies, which sort of scrub the air and keep these air pollutants from ever being released in the atmosphere. And this is normally done through several different types of technologies: scrubbers, baghouse filters, electrostatic precipitators, and catalytic converters in vehicles are all ways that we limit pollution from ever being emitted into the atmosphere in the first place. Remember that most of these chemicals, these 6 major pollutants, occurred as a result of fuel combustion. So as a result, we have put in filters and pieces of technology like the ones you see here in between where the fossil fuel combustion is taking place to where the pollutants or the extra exhaust is coming out. And so these act as a middleman, which filter out all of the toxic chemicals and keep them from ever being released into the atmosphere. Now, we still have a ways to go. While outdoor air pollution is going down substantially in developed countries, air pollution is actually getting worse in undeveloped and developing countries as they are putting up more factories, more polluting factories, more power plants, and more vehicles. And this is because developing countries put an emphasis on economic growth over the health of their citizens or environmental health. So their priorities are in a different place. And in addition, China, which is one of the most developed and economic powerhouses in the world, actually has some of the world's worst air pollution because they continue to put a premium on economic growth as opposed to their citizens' health. So they have the world's worst smog, something we'll talk about in a minute, as well as very bad acid rain deposition and electrical pollution and coal-powered power plant pollution, those sulfur dioxides and nitric oxides, which contribute substantially to the long-term health of their citizens and the environment at large. Now, we're also going to talk, we just mentioned something about smog, and smog is basically a general term for unhealthy air pollutants which accumulate due to fossil fuel production in very urban, very developed areas. Now, a common misconception is that this is not the dragon from The Hobbit. That is actually smog, and he's not really going to play a role in here. Instead, we're going to talk primarily about two different types of air pollution, which is going to be photochemical as well as industrial smog. Going first, we're going to be talking about industrial smog, and industrial smog simply occurs from the incomplete combustion of fossil fuels, particularly in industrial settings as well as power plants. Basically, because of some of the byproducts of coal, it will react with oxygen to form things like carbon dioxide, carbon monoxide, soot, mercury oxide, as well as sulfur. Sulfur dioxide is of particular note because one, it is a pretty severe primary pollutant, but it also can react with sunlight to form sulfuric acid as a secondary pollutant, which will contribute substantially to acid rain, something that we're going to be talking about a little later. And as a result of different regulations from developed countries, we've dramatically reduced smog. Refer back to that graph that we talked about earlier, where most of these criteria air pollutants were going down. However, in coal-burning industrializing countries or developing countries, which are not quite there to the standard as developed countries, these countries face severe health risks as a result of burning these coal power plants and generating electricity for their people, because they aren't necessarily implementing the same policies or the same technologies to mitigate some of these adverse health risks. Now, the second type of smog that we're going to talk about is something called photochemical smog. Now, photochemical smog is actually a secondary pollutant. Photochemical smog actually results from sunlight driving chemical reactions between primary pollutants, the pollutants that we have already been emitted, and different atmospheric compounds. So here we're going to have these different compounds emitted from incomplete burning of fossil fuels. They're going to react with sunlight and then ambient chemicals that are already in the air to form far more toxic chemicals, which can be more severe in nature. Now, basically, some of the main byproducts of photochemical smog are things such as ozone, which, as we're going to talk about in the next lecture, is very good in the stratosphere, but very harmful in the troposphere where we can breathe it, nitrogen dioxide, and many other compounds which can result from these sunlight-driven reactions with primary pollutants. Now, where photochemical smog is usually a problem is in sunny, hot cities with very high populations and very high combustion of fossil fuels that are normally surrounded by mountains. So going back to that thermal inversion layer that we talked about in the previous lecture, in areas where the hot air is above cool air, so the smog or the pollutants can't rise naturally, and particularly in areas where there's a lot of mountains that kind of trap the smog from moving horizontally away from the cities, this photochemical smog can arise simply because the pollutants are sitting there right where they can react with sunlight and ambient atmospheric compounds. And it becomes a huge problem just because there's that cap where we have these huge smog warnings in areas like LA, simply because the pollution can no longer escape. And in these areas, it can irritate the eyes, noses, and throats, as well as cause severe breathing problems if that cap or if that thermal inversion layer stays for a long period of time. Now, this is everything that we have for the outdoor air pollution lecture. I hope you guys enjoyed it. Again, it is a good news story because we are slowly limiting our air pollutants that are causing air problems and causing breathing problems across the globe. We still have some work to do, but it is generally regarded as a good news story. Next, we're going to talk about the ozone layer, as well as ways that we have damaged it and ways that we have repaired it as well. All right, I'll see you then.